Okay, so this was masterfully crafted. As we can see, we have two tiny little nubs right here that we can attach our things. We have a resistor plug right there. We've got these things hooked across and going into the voltage meter. This is attached to the current detector, and then we got our zero, negative, and positives. So right now, with this current setup, we're using 7.2 or so and 6.5, and we're getting 14 and 13 or 14 across the ohm reader and the current reader. As we start to change these a little bit, notice how we get a little bit higher numbers, a little bit lower numbers.
We're
and we can
supposed to record the adjustments for this one.
Are we supposed to do that?
Yes.
All right. This one is 10.219 volts, 10.4 milliamps. Alright, check this out, guys. We were looking at the 1 kilo ohm resistor and a 1.5 kilo ohm. We got some voltages and currents, and they look linear on this graph. So we have this resistor that we are going to replace with this lamp and see if we can get similar results. Okay, so that's kind of a little experiment. Here we have a 2.7 voltage, a really low light, 84 milliamps. That's a really high current. Here we have 4.35, 110.96.
For this one, we're supposed to see that it's non-linear, right? It's not as linear as.
Oh, it diverges. Okay. Get enough points. Let's get 7. Yeah. See?
Non-linear.
Okay, so basically we have a 5 volts channel that's going into a 1 kilo ohm resistor. That's going into this box. Then we're measuring the current. Then we're sending it across a diode. Then we get this digital multimeter measuring the voltage across the diode. And then we've got that going into ground. And so this is a pretty complicated circuit. So what is this here? This is all just zeros. Assuming that's 0. But we also have this one right here. So we have to put this in series. So it's more like 1K plus 0 is the resistance there. 4.441 milliamps. And then what's this voltage? 0.6? Is it always going to read 0.6?
I think that's the standard for a silicon diode.
Okay. Okay, so 1K plus 500 ohms. And that gives us 2.989 milliamps. And our voltage changed across the diode. 0.5616. Okay, so we noticed that when we measure the diode, this is kind of what happens to the current. The current becomes much less as we increase the resistance. So that's kind of cool. So you can see we got the 3 different graphs. This is the linear graph of just the regular resistor. This is the curvature for the lamp, and this is the curvature for the diode.
What is asking
Oh,
you to
voltage
plot?
on the
It's
x-axis.
asking you to plot voltage, right?
Okay.
Exactly. Right. So you look like something similar, the IV curve.
That's nice. It's a little line right there. Sweet. Okay, here we go. We're flipping the diode, and we get no current. And we get 5 voltage. And it doesn't really matter what our resistance is. We're still getting the same values. So that means the diode is working properly. It means that it's shutting everything off, and there's no current flowing. And we're just reading 5 voltages across our power. So we were able to see our sine function on the screen right here. And our goal is to actually measure how fast does it go from here to there. That's really the question. It seems like it's instantaneous, but it's not. Zooming in hella, zooming in more and more and more so we can really get that. Yeah, so now, remember if we have 1,000 here, then 10% from the bottom is like 100 up, which gives us negative 400 on the bottom. And here is B, negative 16. Here is A at 18. And the difference between those two is 35. Okay, there we go. So now we have the 1 volt offset right here, and there's the sine wave. Now I have to zoom in again and basically retest it. Okay, yeah, let's see what this coupling does. Ah, there's the coupling right there. Let's do that. AC.
Oh.
the AC coupling and a capacitor in between, so it removes any offset. Right, so the signal basically moved down.
Okay, so apparently when we switch from the DC coupling here, we have an offset of 1 volt. When we switch to the AC, apparently the offset gets removed here. So now it goes back to the 0 line. Perfect. So we got this negative thing here, and this goes to a resistor. You just plug the resistor in here. Let's connect these two here to there. Notice it has to be exactly along the same strip here. Yes, we have to actually connect this one right here as well. So the little strip right there. Boom. Alright, so this should have worked. We get negative 7.5. We have this thing and this thing, and we'll disconnect those. So now, we just literally plug a third resistor in. Here to here.
And then just
That connects these.
The ends of, say, like this is one you want to be parallel at, right? So it would connect like this end of with this end of the resistor. So you would put a jumper wire on the same row. So like you want it should be of the opposite side.
There we go.
Yeah, it's 5 volts.
Okay, real quick. So now we've added another resistor right here in parallel with that one. As you can see, our voltage is now 5. Awesome.
and then do the last one.
Replace these?
Yeah, replace the voltage with Yep.
Okay, so this last piece, what we did is we unhooked that resistor, and now we are just measuring the current across that. We're getting negative 1.5 milliamps.